What is a white light?
The combination of all the colors in the visible spectrum.
What is a white light?
The combination of all the colors in the visible spectrum.
What is work?
Energy transfer by mechanical means.
What is work?
Energy transfer by mechanical means.
What is an X-ray?
Electromagnetic wave of very short wavelength or very high energy photons. Emitted by an atom with many electrons that is disturbed by the collision with a high energy particle.
What is an X-ray?
Electromagnetic wave of very short wavelength or very high energy photons. Emitted by an atom with many electrons that is disturbed by the collision with a high energy particle.
What are Young's modulus?
Applied pressure, called stress, divided by the ratio of the change in length to the original length, called strain.
What are Young's modulus?
Applied pressure, called stress, divided by the ratio of the change in length to the original length, called strain.
What is the zeroth law of thermodynamics?
If objects A and B are in equilibrium and B and C are in equilibrium, then A and C are also in equilibrium.
What is the zeroth law of thermodynamics?
If objects A and B are in equilibrium and B and C are in equilibrium, then A and C are also in equilibrium.
What is the third law of thermodynamics?
Absolute zero can never be reached.
What is a thermograph?
Picture that shows the temperature of every location in the picture. Thermometer device to measure temperature.
What is a torsional wave?
Material is not only displaced vertically, but also twists in a wave-like fashion.
What is weight?
Force of gravity on an object, F equals mg.
What is a wheel and axle?
Simple machine. If the radius of the axle is a and the radius of the wheel is w, then if the input force is applied to the wheel, the output force is given by F output equals F input, with a.
What is the weak nuclear force?
Cause of beta decay. Weaker than strong nuclear force. Shown to be an aspect of the electroweak force. Carried by the massive W plus, W dash, and Z degree particles.
What is a torque, T?
Equivalent of force for rotational motion. If forces is at a right angle to the radius, then torque equals the force times the distance from the axis of rotation.
What are very high frequency, VHF, waves?
Frequency 30 MHz 300 MHz.
What is the Van Allen belt?
Donut-shaped regions of charged particles around Earth. Created by charged electrons and protons from solar wind and cosmic rays trapped by Earth's magnetic field.
What is the universal gravitational constant?
Proportionality between gravitational force between two objects and gmm/r2.
What is a volt, V?
Unit of measurement of potential difference or voltage.
What is a white light?
The combination of all the colors in the visible spectrum.
What is the uncertainty principle?
Limitation to simultaneous knowledge of position and momentum of particle, dx dps equals h/4p. Equivalent equation for energy and time.
What is a torsional force?
Force exerted to twist an object.
What is a wavelength?
The distance from one point on the wave to the next identical point, the length of the wave.
What is velocity, v?
Displacement divided by the time required to make the change, vector.
What is the timbre?
Quality of sound. Sound spectrum produced by an instrument, characterized by relative amplitudes or harmonics.
What is a vector quantity?
A quantity that has both a magnitude and a direction.
What is a third-class lever?
Simple machine with pivot at one end or bar, the effort force exerted at the other end. The input force between the two, ma less than 1.
What is an X-ray?
Electromagnetic wave of very short wavelength or very high energy photons. Emitted by an atom with many electrons that is disturbed by the collision with a high energy particle.
What is thermodynamics and statistical mechanics?
Studies how temperature affects matter and how heat is transferred. Thermodynamics deals with macroscopic objects. Statistical mechanics concerns the atomic and molecular motions of larger numbers of particles.
What are Young's modulus?
Applied pressure, called stress, divided by the ratio of the change in length to the original length, called strain.
What is a voltaic pile?
Or battery in which chemical energy is converted into increased energy of electric charges.
What is the standard time?
The cesium-133 atomic clock is the standard for the second.
What is a VAD de Graaff generator?
Device using static electricity to produce very large potential differences.
What is a torr?
Measure of pressure using measurement of height of mercury in a glass tube that would create a pressure that balances the pressure of the fluid. Used to be called millimeters of mercury, mmHg.
What is a thermostat?
A device that is part of a system that maintains a constant temperature.
What is the threshold of hearing?
Minimum sound intensity that can be heard, 0 dB.
What is a watt, W?
Unit of power. 1 watt is 1 joule, J, per second, S.
What is a wedge?
Simple machine used to force two objects apart. Examples are the knife, hatchet, or axe, and plow.
What is work?
Energy transfer by mechanical means.
What is a very large array, VLA?
Group of 27 radio telescopes spaced as much as 13 miles apart from each other in Socorro, New Mexico.
What are vocal cords?
or vocal folds. Vibrating source of the human voice.
What is a wave velocity?
Depends upon the material or medium in which it is traveling.
What is the zeroth law of thermodynamics?
If objects A and B are in equilibrium and B and C are in equilibrium, then A and C are also in equilibrium.
What is a wave?
A traveling disturbance that moves energy from one location to another without transferring matter.
How is nuclear fission used peacefully?
Nuclear reactors produce electric power. The energy from uranium fission heats water that circulates through the reactor. The heated water produces steam that turns turbines connected to generators. As is the case with all electric power plants. Only about 1/3 of the energy produced by the reactor is converted into electrical energy. The remaining energy heats local rivers, lakes, or the atmosphere. In the United States there are 104 reactors that provide about 20% of the electricity used by our country.
What would happen to Earth if the Sun suddenly disappeared? How soon would Earth recognize that the Sun's gravitational field was gone?
It couldn't happen instantaneously, because Einstein's special theory of relativity says that no information can travel faster than the speed of light. So, it would take about 8 minutes before Earth would both experience the lack of sunlight and the lack of gravitational force. Many scientists now believe that gravity is the result of mass warping space-time. While the effects of gravity have long been studied and its laws defined, what the force of gravity actually is still is a matter of debate.
Who was the Doppler effect named after?
Johann Christian Doppler, 1803 to 1853, the Austrian mathematician for whom the Doppler effect is named, proposed in 1842 that the color of double stars rotating about each other would depend on whether the star was approaching or receding from Earth. The effect was too small to be measured. But in 1845 Christophorus Henricus Didericus Buys Bal Lot 1817 to 1890, set up an experiment using had two sets of trumpeters. One set remained at rest while the other was on an open railway. Car traveling at the then fantastic speed of 40 miles per hour. Although both sets of trumpeters played the same note, the change in tone was clearly heard. Doppler later extended his theory to the case when both sound source and observer were moving. French physicist Hippolyte Fizeau, 1819–1896, later extended Doppler's theory to light.
What is the charge of electron?
E equals minus 1.602 x 1019 c.
What are alpha particles?
Helium atoms with 2 electrons removed emitted with high energy by some radioactive nuclei.
What is angular momentum?
Equal to the product of its moment of inertia and its angular velocity.
What is an elastic deformation?
When the deforming force is no longer applied, object returns to its original shape. See plastic deformation.
What limits have been established to reduce exposure to noise pollution?
The World Health Organization has recommended that noise during sleep be limited to a level of 35 decibels. And governments are beginning to place restrictions on noise levels in both residential and business environments. In the Netherlands, for example, regulations specify that new homes may not be built in areas of high noise levels, those that exceed average noise levels of 50 decibels. In the United States, employers must provide hearing protection for those who endure noise levels of 90 decibels for more than 8 hours a day.
What is retina?
Screen on back of eye. Has cells that detect light and a neural network that does preliminary processing of the information received.
How do rainbows occur?
A rainbow is a spectrum of light formed when sunlight interacts with droplets. Upon entering a water droplet, the white light is refracted and dispersed. That is, spread apart into its individual wavelengths, just as in a prism. The light inside the droplet then reflects against the back of the water droplet before it refracts and disperses as it exits the droplet. The angle between entering and leaving is 40 degrees for blue light, 42 degrees for red.
What are secondary colors?
Cyan, magenta, and yellow of light, blue, green, and red of pigments.
What is frequency, F?
How many cycles of an oscillation occur per second?
What is the order of colors in a rainbow?
The order of colors in a rainbow goes from longest wavelength red on the outer arc to shortest wavelength blue on the inside of the arc. The full order from outer to inner is red, orange, yellow, green, blue, indigo, and violet.
What are the subfields of physics?
The word physics comes from the Greek physis, meaning nature. Aristotle, 384 to 322 BCE, wrote the first known book entitled Physics, which consisted of a set of 8 books that was a detailed study of motion and its causes. The ancient Greek title of the book is best translated as Natural Philosophy, or Writings about Nature. For that reason, those who studied the workings of nature were called natural philosophers. They were educated in philosophy and called themselves philosophers. One of the early modern textbooks that used physics in its title was published in 1732. It was not until the 1800s that those who studied physics were called physicists. In the 19th, 20th, and 21st centuries, physics has proven to be a very large and important field of study. Due to the huge breadth of physics, physicists today must concentrate their work in one or two of the subfields of physics. The most important of these fields are listed below. The Greek philosopher Aristotle wrote the first known book about physics. Quantum mechanics and relativity, both of these fields study the descriptions and explanations of the way small particles interact. Quantum physics, the motion of objects moving near the speed of light. Special relativity, and the causes and effects of gravity. General relativity. Elementary particles and fields, the study of the particles that are the basis of all matter. Both their properties and their interactions are included. Nuclear physics, the study of the properties of the nuclei of atoms and the protons and neutrons of which they are composed. Atomic and molecular physics, the study of single atoms and molecules that are made up of these atoms. Studies include interactions with each other and with light. Condensed matter physics, otherwise known as solid-state physics. Condensed matter is a study of the physical and electrical properties of solid materials. An exciting new study is that of nanomaterials, leading to nanotechnology. Electromagnetism and optics studies how electric and magnetic forces interact with matter. Light is a type of electromagnetic wave and so is a part of electromagnetism. Thermodynamics and statistical mechanics studies how temperature affects matter and how heat is transferred. Thermodynamics deals with macroscopic objects, statistical mechanics concerns the atomic and molecular motions of very large numbers of particles, including how they are affected by heat transfer. Mechanics deals with the effect of forces on the motion and energy of physical objects. Modern mechanics studies mostly involve fluids, fluid dynamics, and granular particles, like sand, as well as the motions of stars and galaxies. Plasma physics. Plasmas are composed of electrically charged atoms. Plasmas studied include those in fluorescent lamps, in large-screen televisions, in Earth's atmosphere, and in stars and material between stars. Plasma physicists are also working to create controlled nuclear fusion reactors to produce electricity. Physics education research investigates how people learn physics and how best to teach them. Applications of physics. Acoustics. Musical acoustics studies the ways musical instruments produce sounds. Applied acoustics includes the study of how concert halls can best be designed. Ultrasound acoustics uses sound to image the interior of metals, fluids, and the human body. Astrophysics studies how astronomical bodies, such as planets, stars, and galaxies, interact with one another. A subfield is cosmology, which investigates the formation of the universe, galaxies, and stars. Atmospheric physics studies the atmosphere of Earth and other planets. Today most activity involves the causes and effects of global warming and climate change. Biophysics studies the physical interactions of biological molecules and the use of physics in biology. Chemical physics investigates the physical causes of chemical reactions between atoms and molecules and how light can be used to understand and cause these reactions. Geophysics. Geophysics is the physics of Earth. It deals with the forces and energy found within Earth itself. Geophysicists study tectonic plates, earthquakes, volcanic activity, and oceanography. Medical physics investigates how physical processes can be used to produce images of the inside of humans, as well as the use of radiation and high-energy particles in treating diseases such as cancer.
How were the details of the strong force determined?
Examining the kinds of isotopes that exist gives clues about the nature of the strong force. The most stable nucleus, helium-4, has 2 neutrons having spins in opposite directions and 2 protons also having spins in opposite directions. A majority of non-radioactive isotopes have even numbers of neutrons and even number of protons, allowing them to form pairs with opposite spins. Most of the other isotopes have either an even number of protons and an odd number of neutrons or the opposite. Isotopes with both an odd number of protons and neutrons are extremely rare. So, the strength of the strong force clearly depends on the spins of the nucleons. The mass of a nucleus is less than the sum of the masses of the protons plus the sum of masses of the neutrons. The larger the mass difference, the stronger the forces holding the nucleus together and the more energy needed to pull the nucleus apart. Studies of the mass of the nuclei can thus be used to gain further insight into the strong force. Maria Geppert-Meyer, 1906 to 1972, was a German-born American physicist who explained why nuclei with certain numbers of protons and or neutrons, called magic numbers, were extremely stable. Her theory showed that the nuclear force depended on both the spin of the nucleon and its orbital angular momentum. The magic numbers are 2, 8, 20, 28, 50, 82, and 126. Thus helium-4, the most stable nucleus, has a magic number of protons and a magic number of neutrons, and so is called doubly magic. Oxygen 16, calcium 40, and calcium 48, and lead 208, which is the heaviest stable nuclide, are also doubly magic. But, are all nuclei stable? What rays do radioactive materials emit? Among the scientists who explored radioactivity immediately after Becquerel's discovery was Ernst Rutherford, then at McGill University in Montreal, Canada. He and Frederick Soddy found that uranium and thorium emitted two different kinds of rays. One could be stopped by paper, the other required metal about a centimeter thick. Rutherford named them alpha and beta rays after the first two letters in the Greek alphabet. In 1907 he named the even more penetrating rays produced by radium gamma rays. In 1900 Pierre, 1859 to 1906, and Marie Curie, 1867 to 1934, using an electroscope, found that beta rays are negative particles. Becquerel used the same kind of apparatus J. Thomson, 1856 to 1940, had used. See the chapter What is the World Made Of? To measure the ratio of mass to charge of an electron to determine that betas typically travel at about half the speed of light and are identical to electrons. In late 1907 Rutherford demonstrated that alpha rays were helium atoms with the two electrons removed. He had not yet discovered the nucleus. Today we say that an alpha particle is the helium-4 nucleus. Gamma rays were later found to be very high-energy photons.
What is an ultrasonic sound?
Frequencies above human hearing, 20 kHz.
What is a fluid?
A liquid or gas that can flow and assume the shape of its container.
What is fission?
Form of radioactive decay where nucleus splits in two. Extra neutrons and a large amount of energy is released.
What is white light?
White light is the combination of all the colors in the visible light spectrum. When separated from each other, the different wavelengths have different colors. The longest wavelength light is the color red, and decreasing wavelengths result in orange, yellow, green, blue, indigo, and finally, the shortest wavelength visible color, violet.
What is a node?
Locations in a standing wave where there is no amplitude caused by destructive interference.
What makes an object positively charged, negatively charged, or neutral?
The massive nucleus of an atom consists of positively charged protons and unchanged charged neutrons. It is surrounded by a cloud of negatively charged electrons. Normally atoms are neutral, the number of electrons equals the number of protons in the nucleus. A negatively charged object is an object that has an excess of electrons. A positively charged object has fewer electrons than protons in the nucleus.
What is the Magnus force?
Force on a spinning ball that causes its path to curve.
Are there federal standards for using hearing protection?
Federal regulations mandating the use of hearing protection in the workplace state that if an employee works for 8 hours in an environment in which the average noise level is above 90 decibels, the employer is required to provide free hearing protection to those employees. For example, many high school and college students work for landscapers in the summer. Since the average decibel level for a lawnmower is about 100 decibels, and if the employees are working for 8 or more hours per day, free earplugs or earmuffs must be provided to the employees.
What is the first law of thermodynamics?
A restatement of the conservation of energy, net heat input equals net work plus change in thermal energy.
How was the laser invented?
One of the useful applications of quantum mechanics is in each CD or DVD player in your home, or in the laser pointer. It's the device that uses stimulated emission of light predicted by Einstein so many years ago. In 1953, Charles Townes, 1915, of Columbia University, and later MIT, developed and patented the first application that he called a maser for microwave amplification by stimulated emission of radiation. It used a beam of ammonia molecules and later led to the hydrogen maser, now used as an extremely accurate clock. In 1958, Townes and Arthur Shallow described how molecules could be used to extend the maser concept to optical frequencies. After their paper was published, a number of physicists at university and industrial labs rapidly tried to apply these ideas to working devices. In May 1960, Theodore Maiman, 1927–2007, at Hughes Aircraft Company demonstrated an optical maser that used a ruby crystal with a flash lamp. Similar to the camera flash lamp, to put the chromium atoms in the ruby into their excited states. Maiman was involved in a court fight over the validity of his patent for the laser with Gordon Gould. 1920–2005, who worked with Townes at Columbia. In 1973, Gould was awarded the patent rights. Maiman won number of awards, but never the Nobel Prize. While the laser was first described as a solution looking for a problem, over the past 50 years lasers have become a multi-million-dollar industry. Lasers have been constructed using gases, as in the familiar helium-neon, or He-Ne laser. The carbon dioxide laser used to cut fabrics and metals, the argon-ion laser used in surgery, the ultraviolet excimer laser used for eye surgery, and the free electron laser used in research. Lasers made of tiny semiconducting crystals are used in CD and DVD players and laser pointers, as well as optical fiber communications equipment that brings video and the internet almost to your front door. Lasers have revolutionized research in physics, chemistry, and biology.
How far away can FM and AM stations be received?
All electromagnetic waves travel in a straight line while in a uniform medium such as the lower atmosphere. Therefore, most radio waves only have what is called a line-of-sight range. That means that if a mountain range or the curvature of Earth were in the way of the radio signal, the receiver would be out of range and would not receive the signal. This is why most broadcasting antennae are placed on tall buildings or mountains to help increase the line-of-sight range. Waves with frequencies below about 30 MHz are able to reflect off the charged particles in Earth's ionosphere. This is referred to as skip. Instead of passing through the ionosphere and entering space as higher frequency electromagnetic waves do, the lower frequencies on the AM band can be reflected back toward Earth to increase their range dramatically. After sunset, the ionosphere's altitude permits stations to be heard thousands of kilometers from a transmitting tower. A handful of AM stations are clear channel stations. That is, there is only one station in the continental United States broadcasting on that frequency. Those stations can be heard across almost the entire country without interference from other stations. Broadcast FM stations, with frequencies 88 to 108 MHz, penetrate the ionosphere, and so can only be heard 80 to 160 km from the transmitter.
How is it explained using quarks?
Beta decay involves two steps. First, the down quark changes to an up quark with the emission of a W boson. Then, almost instantaneously, the W changes into an electron and antineutrino. Physicists diagram the two beta decay processes this way. When a nucleus undergoes beta decay, the number of neutrons goes down by 1. The number of protons goes up by 1, and an electron and antineutrino are emitted. In terms of quarks and leptons, one of the down quarks in the neutron is changed to an up quark in the proton. And a lepton, electron, and antilepton, antineutrino, are emitted. The change from down to up quark is a flavor change, and that can occur only in beta decay. When a positron is emitted in inverse beta decay, an up quark in the proton is changed to a down quark in the neutrino, and a lepton, neutrino, and antilepton, positron, are emitted.
Who invented the first thermometer?
Although Galileo, 1564 to 1642, is credited with developing the first thermometer in 1592, his thermometer was open to the atmosphere. So it measured a combination of temperature and atmospheric pressure. It was not until 1713 that Daniel Gabriel Fahrenheit 1686 to 1736, developed the first closed-tube mercury thermometer. Combined with the temperature scale he defined the following year. Fahrenheit made a significant contribution to science.
How are the results of collisions in accelerators detected?
A collision between two protons or a proton and antiproton can produce a large number of particles of different kinds. The task of a detector is to find the direction in which each particle is going, find its charge, momentum, and energy, and identify it. Detectors are huge devices. The CDF Collider detector at Fermilab weighs 5,000 tons and is 12 meters, 39 feet, in each dimension. It is operated by a collaboration of about 600 physicists from 60 universities and organizations. Atlas, a toroidal LHC apparatus, at LHC is even larger. It weighs 7,000 tons, is 44 meters, 144 feet, long and 25 meters, 82 feet. In diameter, 2,000 physicists are involved in building and operating this experiment. In both detectors, position detectors locate the particles close to where they are produced in the beam line. Somewhat farther away from the beam line, a strong magnet deflects the paths of charged particles. Outside the magnet are additional position detectors and finally detectors that measure the energy of the particles. The curved paths charged particles take in the magnet are used to find their charge and momentum. Each collision can produce billions of pieces of data, only a small number of which are interesting. Electronic circuits and fast computers use data from the position detectors to decide whether the set of data are interesting enough to be recorded. Atlas produces 100 megabytes of data each second. The entire LHC produces 4 gigabytes of data each second. Enough to fill a DVD disc. Up and down respectively. The proton is composed of 2 up quarks and 1 down quark, while the neutron is composed of 1 up and 2 down quarks. You can check to see that the charges of the quarks add up correctly. Up and down quarks are said to be 2 different quark flavors. Because the quarks have half-integral spin, like electrons and neutrinos. There cannot be 2 identical quarks that have the same quantum properties. Quarks have additional property called color charge that can be red, green, or blue. A proton or neutron must have quarks with one of each of the colors so that they add to white. Just like ordinary colors do.
What is a permanent magnet?
Domains remain aligned after the polarizing magnetic field is removed, resulting in a permanent magnet.
What are the best ways to protect one's hearing at loud rock concerts?
The first protection against damage to the cilia is to increase the distance from your ears to the speakers. In plain English, the farther away one is from the speakers, the lower the intensity of the sound. By simply doubling the distance, the intensity becomes 1/4 of what it was originally. That can work in open areas where the sound can spread. But in arenas or halls the sound can reflect off the ceilings and walls and does not decrease with distance. The second method of protecting one's ears is to dampen the sound waves as they enter the ear. Many musicians, both rock and classical, to avoid gradual hearing loss, now use earplugs to decrease the amplitude of the wave entering the ear. The fluid in the cochlea transfers less energy to the cilia than if the listener were wearing no hearing protection.
Why is it dangerous to look at a solar eclipse?
Looking directly at the photosphere of the Sun, the bright disk of the Sun itself. Even for just a few seconds, can cause permanent damage to the retina of the eye. Because of the intense visible and ultraviolet rays that the photosphere emits. This damage can result in permanent impairment of vision, up to and including blindness. The retina has no sensitivity to pain, and the effects of retinal damage may not appear for hours. So there is no warning that injury is occurring. Under normal conditions, the Sun is so bright that it is difficult to stare at it directly. So there is no tendency to look at it in a way that might damage the eye. During a total eclipse, however, with the Sun covered, it is easier and more tempting to stare at it. Unfortunately, looking at the Sun during an eclipse is dangerous even if totality occurs only briefly. Viewing the Sun's disk through sunglasses or any kind of optical aid, binoculars, a telescope, or even an optical camera viewfinder, is extremely hazardous. The best methods are to use special solar filters, welder's glasses, or a pinhole camera.
What is a solid?
State of matter. Solids retain their shape because strong forces hold the atoms in their places.
What happens to the buoyancy of the ship when cargo and passengers are added?
When cargo and passengers are added to a ship, its weight increases. As the ship's weight increases, it sinks further into the water, displacing a greater weight of water. If it sinks so far that water can spill into the ship, increasing its weight even more, the ship sinks to the bottom of the water. The amount the ship sinks in the water as a result of cargo and passengers can be critical for navigation and maneuverability. Large cargo and cruise ships have numbers on the bow of the ship that indicate how far the distance is between the water line and the bottom of the ship. This distance is called the ship's draft. If the ship has a 6 km, 20 foot, draft and the water is only 5.5 km, 18 feet, deep, cargo and passengers must be unloaded to allow the ship to rise.
What is a lumen, lum?
Unit of measurement of luminous power.
What is the Rydberg formula?
Wavelength of the emitted radiation from hydrogen atom is given by 1/x equals r, 1/m2, 1/n2. The numbers m and n are the quantum numbers of the two energy levels. For example, the red line would be m equals 2, n equals 3. The Rydberg constant r equals 0.01097 nm1.
What is the difference between a motor and a generator?
In each device, a magnet and a coil of wire are employed to change one form of energy into another form. A motor consists of multiple loops of wire placed in a magnetic field. Either the loops or the magnet can rotate. The current through the wires in the field causes a force that results in rotation and thus mechanical energy. Motors in a home are used in fans, hair dryers, and food processors. There are over 100 motors in a modern automobile. The starter motor is the largest and most powerful. A generator does the opposite of a motor, it changes mechanical to electrical energy, but still consists of multiple loops of wire in a magnetic field. Either the loops or the magnet can rotate. In an automobile, a form of a generator, called an alternator, uses some of energy from the engine to charge the battery. Backup generators use the energy from a gasoline engine to produce enough electrical energy to keep some of the lights and appliances running in a house when the electrical power fails. Electric utilities use huge generators to provide power for a city or larger area. The generators get their energy from steam turbines. The heat required to turn water into steam can come from coal, oil, natural gas, or nuclear burners. Wind power uses generators turned by the propeller blades.
What are complementary colors?
Pair of one secondary and one primary color that form what is close to white light.
What is a segmented mirror telescope?
When mirrors exceed 8 meters, 26 feet, in diameter, they are no longer rigid enough to maintain the same shape when they are tilted. The Keck telescope was the first to be built of 36 hexagonal mirrors. The tilt of each mirror is controlled electronically so that they all focus their light rays at a single point. The electronics can position each corner of the mirror to an accuracy 4 nanometers to create the final image. Constructing the telescope of multiple smaller mirrors greatly reduced the cost of the telescope. The large binocular telescope consists of the Keck I and Keck II 10-meter, 33-foot, telescopes. When they are used together, they can detect the interference of light from a star and thus determine its size and location much more precisely.
What would happen if you had a multitude of pinholes at the location of the lens?
The reproductions from all the pinholes would be at the same location, and many more rays from the object would end up at the same place on the image. The image would be much brighter. So, You can model the formation of an image by a lens as a collection of reproductions of pinholes. The larger the lens, the brighter the image.
What is a wedge?
Simple machine used to force two objects apart. Examples are the knife, hatchet, or axe, and plow.
What is the timber?
Quality of sound. Sound spectrum produced by an instrument, characterized by relative amplitudes or harmonics.
What is mathematical physics?
Study of how physical processes can best be described by mathematics.
What is a greenhouse gas?
Gases transparent to light and short-wavelength infrared radiation, but are opaque to the long-wavelength infrared emitted by warm objects. Examples are carbon dioxide, methane, and water vapor.
What is a liquid?
State of matter in which the forces keep the atoms close together, but they're free to move. A liquid is a fluid that flows freely and assumes shape of its container.
Why does a rubber balloon that has been rubbed in your hair stick to a wall?
The attraction between a charged balloon and a wall is the result of electrostatic forces. When rubber is rubbed on human hair or a wool sweater, electrons transfer easily to the rubber balloon. The balloon is charged by rubbing the hair or sweater. Fuzz may stand up as a result of the excess positive charges repelling each other. When the balloon is brought near the wall, it polarizes the wall, moving the positive sources toward it and repelling the negative charges away. The negatively charged balloon is attracted to the many positive charges in the wall. As long as the electrostatic force and frictional force between the balloon and the wall are stronger than the gravitational force pulling the balloon down, the balloon will remain on the wall.
Is energy conserved?
While total energy is conserved, the kinetic energy before the collision is much greater than the energy afterward. Much of the energy goes into bending metal and breaking glass and plastic. Automobile crash reconstruction is a way of using conservation of momentum. to figure out the speeds of one or both of the cars before the collision. Kinetic energy is not always converted to other forms of energy in collisions. The toy Newton's cradle has a set of steel balls that swing on strings. In these collisions, kinetic energy is almost totally conserved. The incoming ball stops when it hits a second ball, and the second ball moves away with the same speed. And thus kinetic energy, as the incoming ball had. Collisions of pool or billiard balls is another case where kinetic energy is conserved. This kind of collision is called elastic, while the case of cars colliding is called inelastic. A hot object has thermal energy. How can it transfer this energy? What happened to the increased thermal energy of the eraser and your hand, or to the block and the table? A short time later all will have cooled. They have transferred their thermal energy to the cooler surroundings. Energy transfer that results from a difference in temperature is called heat. Heat always flows from the hotter energy sources to the cooler objects, energy receivers. Thermal energy can be transferred in three ways: conduction, convection, and radiation. Conduction occurs when two objects are in contact, like when you put your hand in hot water. Convection is the motion of a fluid, usually air or water. The fluid is heated by the hotter object, then moves until it contacts a colder object where it heats that object. You can think of convection as two instances of conduction. Radiation is infrared waves that are emitted by hotter objects and absorbed by colder ones. You can feel radiation if you bring your hands near a hot electric burner on a stove. The sun heats Earth by radiation.
What is a second-class lever?
Simple machine with effort force exerted at one end or bar. The input force applied at the other end, and the pivot between the two. Ma less than, equal to, or greater than 1.
What is the difference between force and pressure? Why does the stiletto heel of a woman's shoe sink deep into the ground while if she wears a running shoe the heel does not?
The force on the two heels is the same. What is different is the force divided by the area of the heel. The quotient of force divided by area is much larger on the stiletto heel. That quantity is called the pressure. As an example, consider the case of a 110 pounds, 50 kilograms or 490 N. Woman who first wears shoes with heels 1.5 centimeters by 1.5 centimeters. The area of each heel is about 2.2 square centimeters. Assuming that she puts all her weight on the two heels, the pressure will be 500 N/4.4 square centimeters or 4.5 N/cm2. Pressure is usually expressed in pascals. Pa, or N/m2. In this case the pressure would be 1.1 million pascals or 1100 kPa. If she were to wear running shoes with heels about 7.5 by 7.5 centimeters, then the pressure would be only 45 kPa. The pressure of air is about 101 kPa.
What is a rainbow?
Spectrum of light formed when sunlight interacts with water droplets. Angle between entering and leaving is 40 degrees for blue light, 42 degrees for red.
What is a wheel and axle?
Simple machine. If the radius of the axle is A and the radius of the wheel is W, then if the input force is applied to the wheel, the output force is given by Foutput equals Fput, with A.
Why do we see specific colors?
When we see colors, we are seeing only part of the spectrum of colors that make up white light. The rest of the spectrum is missing. Selecting the color seen can be done in three ways. You can view the object through a transparent material that transmits only some part of the spectrum while absorbing the rest. The object may be colored itself. That is, it reflects part of the spectrum while absorbing the rest. Finally, the spectrum can be physically separated, as it is by interference or by refraction by a prism or rainbow. For example, theatrical gels on spotlights produce colored effects for a stage show. Snow reflects all of the spectrum so it appears white. But green paper reflects only the green part of the spectrum. A black cloth absorbs all light, and so it appears black.
What is subtractive color mixing?
As opposed to the mixing of light, additive color mixing. Subtractive color mixing occurs only when combining dyes, pigments, or other objects that absorb and reflect light. For example, you could shine white light through two colored filters or gels. Or, you can reflect light from colored surfaces. If you shine white light on a blue wall, the wall absorbs red and green but not blue. So if we know what colors are reflected, we know the color of the object. The primary pigments or dyes are magenta, which reflects blue and red light but absorbs green, cyan, which reflects blue and green but absorbs red, and yellow, which reflects red and green but absorbs blue. These are the same colors as the secondary colors obtained when mixing light. Note that if we combine magenta, cyan, and yellow, the red, green, and blue are all removed, leaving nothing, that is, black. Blue is light in the range of 400 to 500 nanometers. Green is roughly 500 to 560 nanometers. Yellow is 560 to 590 nanometers, orange 590 to 620 nanometers, and red beyond 620 nanometers. It may seem surprising that yellow filter transmits green, yellow, and red. But the eye is not very sensitive to red in comparison to green and yellow. That's the same reason that the transmission of the blue and indigo filters beyond 660 nanometers does not impact what the eye sees. Finally, note that purple is a mixture of blue and red.
What happens to the thermal energy in the surroundings?
They get warmer, so their thermal energy increases. Then they transfer this energy to a colder object. Earth is warmer than the space around it, and so it radiates energy into space. When that energy reaches another planet or star, those objects are warmed, and so on through the entire universe.
Does the momentum of your hand change?
Of course, your hand is just a part of your body. And if you are standing firmly on the ground, your body is unlikely to move. Let's pick a simpler situation. Suppose you are sitting in a desk chair with wheels on a smooth floor and you catch a heavy ball thrown by someone. In this case, you and the chair will roll backward. In other words, the momentum of you and the chair will increase as the momentum of the ball decreases.